Hi folks, welcome to 6.1, area between curves, and we're going to take a look at example number 3 from the practice. So, example number 3 says find the area of the region bounded between the graphs of f of x equals x and g of x equals x to the fourth. So let's go ahead and start with our color coding of the graphs. So I know that the linear function is my f of x, and that's in the red on the Desmos graph. And that g of x is my x to the fourth, and that is in blue on Desmos. And so I'm going to start off with my general formula of area equals the integral from a to b of the top curve minus the bottom curve, dx. Now again, we can find our a and our b from the picture, okay? So let's use the graph to find our a and b, and then we're going to confirm it using algebra. So I can see that the region that I'm trying to find the area of is this region right in here. And I can see that they intersect first at an x value of 0, and then they cross again later at the x value of 1. And so if I fill that into my equation along with the functions, I will get that the area equals the integral from 0 to 1 of the top curve, which is the red one, x, minus the bottom curve, which is x to the fourth, dx. And so this is what I'm going to find my integral of so that I can find the area of that green region. Before I do that, though, I'm going to go ahead and algebraically find these two coordinates or intersections. So for the intersections, I'm going to find f of x equal to g of x. And when I do that, I get x equals x to the fourth. Now, one thing that we want to do is we want to approach this the same way we do a quadratic, and we're going to subtract the x to the other side and set everything equal to 0. So we'll get x to the fourth minus x equals 0. Now we're going to go ahead and factor, so x cubed, x times x cubed minus 1 equals 0. And we're going to set each part equal to 0. So x equals 0, or x cubed minus 1 equals 0. And we can add the 1 to both sides here and take the cube root. And there we have our a value, or the first bound. And then we have our b value, or the top bound. Okay? So again, as you go through these questions, make sure you know how to find the bounds algebraically as well as from the graph. All right, so let's go back up to our area problem, and let's start finding our antiderivatives. So the antiderivative of x is 1/2 x squared minus the antiderivative of x to the fourth is x to the add a power, or 5. And then in the front, what's the reciprocal of 5? 1/5. And I'm going to draw the line and put a 1 and a 0. All right, let's move this over here so we have a little bit more room, because we're going to plug in our 1 first, and then we're going to plug in 0, and we're going to subtract the 2. So I have 1/2 times 1 squared minus 1/5 times 1 to the 5th minus 1/2 times 0 squared minus 1/5 times 0 to the 5th. And as it turns out, this entire last term goes to 0, because 0 squared is 0 and 0 to the 5th is 0. And so what I am left with is 1/2 minus 1/5, and that's a pretty straightforward computation. This is the same as 5/10 minus 2/10, which gives me an area of 3/10. All right, so the area of that green region is 3/10. All right, so that's it for question number 3. Come on back. We still have 5 more practice problems to take a look at. All right, see you there.